Hey Global Impact students, this is Mr. Ellinger. This lesson is on solving inequalities using addition, subtraction, multiplication, and division. Two learning targets for this lesson. The first one is to use addition or subtraction to solve inequalities. And the second one is we also want to be able to use multiplication or division to solve inequalities. The central understanding for this lesson: in the same way equations are solved using properties of equality, inequalities are solved using the addition, subtraction, multiplication, and division properties of inequality, and they're very similar. When multiplying or dividing by a negative number, it is necessary to reverse the inequality sign. That's the one difference about inequalities. Anytime you're solving an inequality, you have to be very careful when you're multiplying or dividing, especially if you're using a negative number. So here are those addition property and subtraction property of inequality that I was talking about, and they follow right along with addition and subtraction properties of equality. So here our first one, we have our addition property. Let a, b, and c be real numbers. If a is greater than b, then a plus c is going to be greater than b plus c. If a is less than b, then a plus c is still going to be less than b plus c. And this property also holds true for greater than or equal to or less than or equal to. So over here in this diagram, it shows you graphically what's going on. Here, if you have b on a number line, a on a number line, we don't know what the values of b and a are, and we don't really need to. But in this visual representation here, we know that b is less than a because b is more to the left than a. If I add some value c to b, I'm adding, so that's going to move b from here over to here. So here's b plus c. If I take a and I add c to it, again, the same exact value, it's going to move a from here to here. So we're adding the same value, so we're moving b and a to the right by the same amounts, by the same interval, the same increment. So in this visual representation, b plus c is still going to be less than a plus c. That's not going to change. Same thing works with subtraction. If I have a and b on a number line, in this graph, a is less than b because a is to the left of b. If I subtract c from a, it's going to move a. That difference would be over here. If I subtract c from b, the difference is here. C is the same amount. I'm subtracting the same amount from the left side and the right side. Think of the scale and the balance. I've got to keep the balance. So a minus c is still going to be less than b minus c. Multiplication. This is where it gets a little interesting. Let a, b, and c be real numbers with c greater than 0, meaning c is a positive number. Anytime you see c greater than 0, something greater than 0, a variable, it means that that variable is positive. That's how we need to interpret that. So if a is greater than b, then ac, the product of a and c, is going to be greater than the product of b and c. If a is less than b, then the product of ac is going to be less than bc. Okay, and again, this is if c is positive. So here's a visual representation of that. If I take negative 2 is less than 3, so here's 3. If I multiply negative 2 by 2, I get negative 4. If I multiply 3 by 2, I get 6. So those products, this product, 2 times negative 2, is going to be less than 2 times 3. And as you can see, if there was a gap, if you will, between negative 2 and 3, when I multiply both sides of the equation by some positive number, the gap actually increases. The gap is now 10 units. The gap was, 5 units. Now the gap is 10 units. So the gap's doubled. I'm multiplying by 2. That's kind of interesting, don't you think? Okay, so the second case we have to consider here is that if we let a, b, and c be real numbers with c less than 0, okay, so this time now c is negative. If a is greater than b, then ac, the product of a and c, is going to be less than b and c, b times c. So look at that. A greater than b, multiply both sides by a negative number, now the inequality is reversed. Same thing here, if a is less than b, then the product of a and c is going to be greater than the product of b and c. Again, all of this assuming that c is negative. So graphically, here we have 3 is greater than 1. Okay? But if I multiply 3 by negative 2, 3 times negative 2 is negative 6. Negative 2 times 1 is negative 2. Well, if you look at where those two products are on a number line, -6 is further to the left than -2, which means it is less than -2. So the product, after we take this inequality and multiply both sides by -2, our inequality needs to be reversed to keep the truthfulness of the statement. That's why we reverse the inequality, or flip, if you will, the inequality, to keep the truthfulness of our statement. And this works much the same way with division down here. If A is greater than B, then AC, A divided by C is greater than B divided by C if C is positive. But if A is greater than B, AC is less than BC if C is negative. And here are some examples. All right. And over here to the right, I have a here's why it works explanation. Multiplying or dividing each side of an inequality by a negative number changes the meaning of the inequality. You need to reverse the inequality symbol to make the inequality true. So here is an algebraically worked out problem. 3 greater than 1. True statement. Multiply both sides by -2. -2 times 3 over on the left, -2 times 1 on the right. Perfectly fine to do that. I can multiply both sides of an inequality by anything I want. So the question is, what goes in this gray box? Well, if I simplify the two sides, -6, -2, how are they related, or how do they compare to each other? Well, -6 is now less than -2. So the reversed inequality symbol needs to happen to keep the truthfulness of the statement. Okay? All of these things that we're doing to these equations and inequalities are perfectly fine as long as we don't change the value of the original equation, as long as we don't change the truthfulness of the equation. If we start off with something that is true, or an open equation, if you will, or inequality, everything that we have to do has to be legal. We have to follow correct properties, definitions, and so on. All right, so here we want to solve and graph some inequalities. Our first inequality, n minus 5, is less than -3. So we're going to add 5 to both sides because we're subtracting 5. We're trying to isolate n, so we're going to add 5 to both sides. This makes a 0. So we isolate n. N is less than -3 plus 5, do it exactly as it reads, is 2. On a number line here is 0, so 2 is going to be over here. Less than 2, open dot. Less than 2, everything to the left. There's our graph. Next example, here's y on the right side of our inequality. We're adding 12 to it, so we're going to subtract 12 to isolate y. So we subtract 12 on both sides here. This gives us a 0. We have a y on the left. Still have a greater than or equal to symbol. -1 minus 12 is -13. So -13 is greater than or equal to y, or another way to think of this is y is less than or equal to -13. A lot of times with inequalities, we like it when the variable's on the left because it makes a little more sense to us. So if we're going to graph this, here's 0. -13 is way over here to the left, so we'll just put a dot on -13, and this is a closed dot this time, right? Because it's equal to, inclusive, includes 13. Less than, we're going to the left. So there's my graph. Okay, and these don't have to be scaled perfectly. We don't need to spend a lot of time, putting out tick marks 1, 2, 3, -1, 2, 3. Just say, all right, here's 0, here's -13 over here. Put your dot on there, open or closed, and then your arrow either direction. All right, third example, -5x greater than -10. We need to isolate x. -5 times x, so we've got to divide both sides by -5. Oh, I'm doing inequalities. I just divided. I divided by a negative. -5 divided by -5 gives me an x, coefficient of 1, but I just divided by -5, so I have to flip my inequality, reverse my inequality. -10 divided by -5 is 2. So my solution is x less than 2. All x values less than 2 satisfy the original inequality. So here's 2. It's less than, so I'll put it open. Graph out to the right. Got a little crazy there with that one. All right, fourth example, c divided by 8 is greater than 1/4. Well, the opposite of divide by 8 is to multiply by 8, so let's multiply both sides by 8. The 8s cancel, if you will. They're not really canceling, but what we're doing is we're creating a coefficient of 1 here on C, so we get C. We just multiplied both sides by a positive 8, so we keep our inequality sign the same. 1/4 times 8 is 2. Okay, C greater than 2. Here's 2 to the right of 0. The greater than, that's an open dot, arrow to the right. Okay. Now, just to kind of reinforce this open versus closed, here's 2, right? We want a graph that represents C greater than 2. Just to the right of 2, and I can't get close enough, but let's just say that at that little tick mark that I drew, that was 2.001, and it would be much closer than that, more than likely. Well, 2.001 is a solution to this inequality, C greater than 2. So I want to make sure that 2.001 is on the graph, meaning in the part where I draw the line, they call it shading, but we're not really shading, we're just drawing an arrow. So if this is 2, every single value to the right of 2 has to be on that line. Now when I draw the open circle, granted, there's some values to the right of that tick mark that are included in that circle, but again, this is just a visual representation of what's going on. The open circle on 2 means, think of a hole on 2. Hole at just the value 2, but everything to the right is a part of that solution. We call that a solution set. It's a set of numbers. Any value greater than 2 is a solution, and it's a set of numbers, an infinite set of numbers, and we'll talk about sets more here in a few lessons. Our last example here we have one where we have a fraction in front of a variable, so we have a -2/3 times b less than or equal to -4. The opposite of multiply by b is to divide by b, and one way to think about this is we could go ahead and divide by 2/3. But then this involves, okay, -4 divided by a fraction. What do? Do I need my calculator? No, I don't need my calculator. So let's not remember. Our goal is to create a coefficient of 1 on b. What can we multiply this -2/3 by so that the product of all of that would be 1? Well, anytime you want to get a 1, take your fraction that's there, multiply it by its reciprocal. But in this case, the fraction that's there is negative. So the reciprocal of that is also negative. We have -3/2 times -2/3. That product, when we multiply it out, we'd get 6/6, but that's 1b or b. We're going to multiply this side by -3/2 as well. But red flag should go up. Oh, I'm working with inequalities. I'm multiplying both sides by a negative number. My inequality sign needs to change or be reversed. -4 times the -3/2. So we're multiplying a whole number by a fraction. So we'll put the whole number over 1. And this brings up an interesting point here. This -3/2. Let me write this to the side here. -3/2. Well, is that the same as -3/2? Or 3/2? Or does it go out in front? Well, the answer is any of these. Any of these three are correct. Negative in front of the fraction. Okay, so a negative sign in front of the whole fraction is the same as -3 in the numerator over 2. It's the same as 3 over -2 in the denominator. So you can have the negative in front of the fraction, you can have the negative in the numerator, or you can have the negative in the denominator. Okay, this does not mean, does not mean -3 over -2. Negative divided by a negative is positive, so this would be 3/2, okay? So these are not the same as these. So just wanted to bring that up. So -4/1 times -3/2. We're going to get a positive 12 in the numerator, a 2 in the denominator, that's a 6. So b is greater than or equal to 6. So I'll just put a mark over here and put a 6 there. This time we've got a closed dot. Greater than 6 is everything out to the right. So there's our graph. And that is how we graph inequalities. We got to know the difference between an open dot and a closed dot, know which direction we're going. Have a great day.